Welcome back to Power of Numbers, our tutorial. My name is Shumaila Bhatti, and we will be performing linear regression in this tutorial. Linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variables by fitting a linear equation to the observed data. Let us navigate over to R to show you how we do it. In R, if we look at the first line of code, we are going to show you by using the LM function that the independent variable ADMI A5 and the independent variables political record and video game violence are modeled into this model. We create a model using this equation where y is on the other side of the tilde and political record plus video game violence, the two independent variables, are on the other side, which is x1, x2 on the other side of the equation. The model estimates the relationship between ADMI5 and the predictors, providing the coefficients that describe how changes in the predictors are associated with changes in the dependent variable. We now run this model, and to get the results of the model, we use the summary function like we did previously with the AOV. This function provides a detailed summary of the linear regression model. It includes the estimated coefficients. It shows us the standard errors, the t-values, the p-values, and it also displays the multiple r-squared and the adjusted r-squared, the f-statistic, and the p-values for the model that we created. This here shows the results that political moderate, political conservative, and video game violence all were significantly associated with the statement's agreeability that if a man is threatened, he should be ready to fight. Most of the association in the model was from conservative, and the model is also statistically significant at 0.05, at 0.01 not so much. However, it still works at 0.01 as well. To get the confidence intervals for the estimates here, you can use the confint function to plot the diagnostic plots to determine if your model is based on the correct assumptions. You use the plot model name function. You will get the residual versus fit plot, which shouldn't be a smiley face or a sad face. So this looks good. However, the residual versus the residuals don't seem to be normally distributed. They should be. However, that might also be because of fewer variables and smaller data set. Here we have the scale and location. This also seems acceptable, except for maybe these outliers up top here. And then we also have the residuals versus leverage. You want to make sure that they're not closer to the Cook's distance, which would be shown as like a dashed line. Another important table that you can use, that you can create using APA formatted regression table is using the APA regression.table function. It's apa.reg.table and then your model name. And as you type it here, it will show you this output. You can copy paste that as is, or you can also output it as a Microsoft document. I hope this code was helpful, and I hope that the tutorials were able to show you what you can do in R, and this is just the tip of the iceberg. There's so much more that you can learn, and I hope you can use the resources that have been provided to you in the book, and leave us some feedback with how we can improve this in the next editions, and good luck with doing this going forward. Thank you for watching our tutorials.